Good evening, guys. All right. So, welcome to the third session for SQL. Uh, in the last class, we covered different kinds of selection criteria that you can use to filter the data. So, we looked at logical operators. We looked at different kinds of logical operators. We looked at we looked at between, we looked at wildcard matches when you want to match by a pattern. Post that, we looked at different kinds of aggregate functions, numeric aggregate functions. So we looked at specifically count, sum, average, min, and max, and we saw how you can use multiple such aggregations in your data to summarize your data. Post that, we just started looking at group by clause. So we'll continue from there. But before we get to that, there were 4 questions which I had asked you guys to solve. So I'll just paste the solution for all 4 of these. So the first question which I had asked you to do is find distinct department ID where either condition A or condition B is true. So condition A is a combination of 2 conditions. So salary, and the other is on department ID. And second is any city other than Chicago. So these are the 2 conditions. And because it says either of A or B is true, so we'll connect both of these by an OR. So the solution for this is this one. So first of all, I first broke down the problem with a select star. Say select department ID. So the question is asking for 2 conditions. So the first condition was salary between 100K to 200K and department ID 10. So this is my combined combination of both of them, which becomes the entire condition A. And condition B is any city other than Chicago. So for that, we are using not city equal to Chicago. And we have to connect the first entire of condition A and entire of condition B with an OR. So we do that. And then you use this. Let me run this query. So here you get all your output. I'll just paste this code here for you guys to tally your, sorry, hold on. This. Control C. So this is the question number 3. Then the next question was find the total number of records in table employee. Is there any missing row in ID column? Is ID the unique column? So here we are going to use the count function, and in order to find the total number of records, we use count star. To find any missing rows in ID column, you do count of ID and you compare the output of that with count star. If that is equal, that means the total number of non-missing entries in ID is exactly equal to the total number of records. Alternatively, you can say that there are no missing records. And to find unique, if ID is unique, you do count distinct of ID. So essentially, this would be your query. You say count star as total number of records, count of employee ID as total number of IDs, non-missing IDs, and count distinct employee ID gives me the distinct unique employee ID count. So if I run this query, so all 3 are exactly similar. That means that there are no missing records in ID, and also ID is the unique column because it exactly matches with the total number of records. So I'll just copy this. This is for the next question, which I had asked you guys to give it a try. The third question was, how many employees were hired in the year 2016? So there are multiple ways of coding the year 2016. We will use the between logic for this. So how many employees? We'll use count star. And the condition would be where hire date between 1st January 2016 to 31st December 2016. Now remember, between will include the 2 upper and lower limits that you specify. So you should code it accordingly. So this becomes the third question's output. And the fourth one is, oh, I should also run it and see how much does it come out to be. So there are 20 such employees. The fourth question was how many employees are from city Houston and department ID 5. So two conditions. One is city is Houston and department ID 5. So I should do count star because how many employees? So count star from the table where city is Houston and department ID is equal to 5. Run this query. Also copy it out. So the output should be 10. All right, so these were the 4 questions which we were pending from the previous day's exercise. So now we will move on to day 3's content. So today, first we are going to focus on group by. Let's look at here. So group by clause, just close out this one here. Group by clause groups rows that have same value in a specified column into summary rows. So what that means is, up till this point, we are doing simple count star, sum of a numeric column, average of a numeric column for the entire data set. Now, if I want to break it up, that summarization by, let's say, a particular column, for example, in the employee table, if I want to break it up by city, so then I will have to use this group by logic. We looked at one example before we broke for the day or on Tuesday or Thursday, sorry. So this was the example. Here we were trying to find the total salary for each city for the particular table. So how do we write it? We first have to mention the field by which we want to do the group by. Then we mention the aggregation. So sum of salary, we'll use that. And then we give it a name as city sal. Then we have to mention from which table. Now group by will always come after you specify the from. Okay, this is very important. You should remember this, that group by will always come after from. If I run this query, I'll just drag this down. Yeah. So what do we see? That there are 4 cities, and for each city, the total sum of salary comes out to be these particular values. Okay. All right. Let's look at one more example. Let's say I want to look at the sum of salary as well as minimum salary by department ID. So let's say I want to have multiple aggregations to be present in the same query. So the question is, by department ID, I want to see the total salary as well as minimum salary. So first I have to give the field by which I have to do the summarization. Then next I have to mention the field. So the first aggregation is sum of salary, for which I'm giving a name TOT underscore sal. And the next summarization would be the minimum of salary. So min salary as min sal from table classwork.employee group by department ID. Okay. So see, for each department ID, it is giving me the total salary as well as the minimum salary. So essentially what this is doing is, first, the way the algorithm works is, first it breaks up the data by the group by column. So think of it like virtually it is breaking up that entire 299 observations into 10 parts. So the part 1 would be where department ID is 1, second would be where department ID is 2, and so on. Then it is trying to find these aggregations. So for department ID is equal to 1, it will look at the salary column and sum all of those values and give me the total salary as this. Similarly, for minimum salary, it is going to look at all the records where department ID is 1 and find the lowest salary and give this as the output. Then it will move on to the next department ID and do similar aggregations. It will continue to do this till all values of department ID are summarized. Okay. Now, what if I want to also, this is already in ordered format, but let's say I want to sort this by, mm, let's say, by total salary. So I want that department ID, which has the highest total salary, to appear at the very top. So I will copy this, paste it here. And in to sort, we know we have to use the command order by, and I want to sort it by total salary. Okay. So we'll use the alias 123. Now from previous class, we know that when we specify uh, a few columns or computed columns as well as exact raw columns in the select statement, they can actually be numbered. So my because department ID is the first column I'm writing here, that is column is equal to 1. Sum of salary is the second column or the second output. So then this becomes column number 2. Minimum salary is the third column. So that becomes column number 3. So I want to sort the output by sum of salary in descending order. So I can write it as order by 2, then the order. If I don't write descending, then it will do smallest to largest. But I wanted to sort from largest to smallest. So if I go and run this now, see, it has sorted the data by total salary in descending order. Okay. All right. Now, what if I want to group by two separate fields? Up till this point, I'm grouping by a single column. What if I want to group by multiple columns? I'm going to look at another data which has been provided to us called products. I'll just open and show it to you. So products has these 4 fields: product ID, product name, category, and price. Let's look at a quick preview. So it has a particular category. For each category, there can be multiple products. This is its ID and corresponding name, and this is the price. I have just simply imported that product CSV into BigQuery. Now, let's say I want to look at the total number of products by category as well as product name. So I want to group by 2 fields. So I have to first write select, followed by the first field by which I want to do the group by. Second, let's say I want to group by product name. Then count star as total listed product from classwork.products. Now here I want to do the summarization by both category and product name. So in group by, I will have to mention it in that particular order itself. So group by category followed by product name. Let's also use order by. So let's say in order by, we do it by this calculation that we are doing in descending order. So I'm going to say 3 DESC. Let's see how the output looks like. So what did we do? If you remember the data, we can definitely see that category is repeating, and within category also there can be multiple fields. For example, in jewelry, you see that there is ring and bracelet. If I scroll down, we'll see more of jewelry. So there are 3 necklace items with different product IDs. So maybe there are 3 different styles of necklaces which are listed, which have different prices. Then again in ring, we have one more entry with product ID 32, and at the very top it was product ID 64. So just by looking at this data, we know that category is not a unique field and product name is also not a unique field. So I want to look at the total number of listed products by category and product name. So then I say the first field by which I want to summarize, followed by the second field, and then I write the summarization. I want to look at the total count. So I will say count star and give it a name as tot listed prod. Then from table, then group by. Because I want to do the summarization by both of these fields, I have to mention them in that particular order itself. So I want to first group it by category. Within category, I want to group it by product name. So I say category followed by product name. And then I want to sort it by largest to smallest. So see, largest to smallest. So this is exactly how the output looks like. Okay. All right, let's look at few more questions on this so that the concept is fully clear for us. Okay, so I think there's one question which we can solve for this. So the question says, which department has the highest number of employees? Okay. In the solution for previous part, which city has the lowest average salary? Okay, let's look at the first part. The first part is saying which department has the highest number of employees. So looking at this question, I know that this is referring to the employee table, and we have to look at it by department. We have to break up the output by department. So we have to do group by department. Then next part is highest number of employees. If I look at number of employees, I know that I have to do count of employee ID. And in order to see highest, we can use order by. So I know the three elements that is going to be needed to solve this question. Okay, so let's say select department ID, count of employee ID as emp count from classwork.employee, and I have to break it up by department ID. So I have to say group by department ID. And the last part of the question was highest number of employees. So if I list the output from highest to lowest by this field, then the first entry that I get is going to answer my question. So I say order by to DESC. If I run this query now, see, it's listed in that order. So the department ID with the highest number of employees is 39 and the department ID is 5. Okay. So the first question we've answered. The second question says in the solution for the previous part. So what is the solution for the previous part? Department is equal to 5. Which city has the lowest average salary? Okay. So now here we want to look at in this part, we want to include city and average salary. Okay, so let's copy out this part. Forget about the order by over here first. So here in the solution for the previous part, so now we want to break up the summarization by department by city also. So within department, I want to also break up these 39 employees by city. So I'm going to add city here. Let the count sit there. The part that we want to look at is average of salary. As average salary. Now in group by, we have to group by both because we want to break up this 39 by city also. So we have 4 cities. Now comes the order by part. So in order by, So in order by, we want to look at the city which has the lowest average salary. So average salary is lowest. So if I sort this by average sal, just average sal, because let me see if I write average sal, if it will work or not. Let me see. 1 second. Okay, it works. All right. So what did I do here? Instead of mentioning it by the alias 1234, I'm using the calculated field name exactly as it is. Okay. Now, this is a small thing that you should keep in mind whenever you're working with a different RDBMS. So certain RDBMS will let you use the name of a calculated field. So what am I doing here? I'm creating this average salary in this query, and I'm using the calculated field in the query also. So I'm creating it also in the query, same query, and using it also in the same query. This is not allowed in all RDBMS. In a lot of RDBMS, if I use this exact name here in order by, it will give me an error. So the safe bet in that case is to use this alias 1234, depending on the order in which you are specifying it. But BigQuery doesn't give you an error and it is correctly calculating it. So we can go ahead and use the field which we have created. Okay. All right. So the question was for department ID 5. It says in the solution for the previous part, which city had the lowest average salary. So if I scroll down, I can see that the first entry for department ID 5 was for city Houston, which had an average salary of 61K. Okay. All right. So the answer to the second part is Houston. Okay, because if I scroll down, see, for the next entry of department ID 5 is Chicago, and the average salary for that is 69K almost, because we have ordered it by average salary. But did you see we had to do some bit of scrolling in order to find our exact output, because we did not filter it out by department ID. So the next part that we are going to work on is exactly going to help us with this. Conditional group by. Okay. So what does that mean? That means if I want to filter out the output by a particular filtering criteria and then use that to do the summarization. So in this same example, I was only interested in department ID 5, correct? I did not care about the rest of the department IDs. So if I take this query, paste it here, and after from, if I say where department ID is equal to 5 and run this query. Now see, the entire output is only for department ID 5. So what did we do here? In our previous query, what happened? That it was doing the summarization by department ID and city and giving me all combinations. So department ID ranging from 1 to 10 and city ranging for the 4 cities which we have, these 4 cities. So it was creating a combination of both of them and then creating these summarizations. So in order to find the city which had the lowest average salary for department ID 5, we had to scroll through the data to find the department ID 5's first entry and then see that, okay, the corresponding city was Houston. But now, if I combine this clause with a where condition, so how is the algorithm working? First, it is going to look at the table. Okay, it is going to look at this entire table, and then it is going to first apply this where condition. So first of all, it will take the entire table, filter it out only for department ID 5. Then it sees that, okay, there's a group by clause. So it groups by department ID and city. Now, because department ID is 5, it will only give 5 here because we have filtered it out. And then for the total entries, I think it is 25, 38, 49. So for the 49 entries, for department ID, 39, sorry, 39 entries in department ID 5, it broke it up by city and first calculated the total employee count. So for each department ID and city, it broke up the employee count or the total number of records. And then it looked at the average salary. Looked at the salary column, created the average of it for the combination of department ID 5 and corresponding city. And then it did a order by the average salary. So smallest to largest. So a conditional group by means that when I want to put a filter on the data first and then group by and then do a summarization using group by, then I can use where in conjunction with group by. Okay, let's look at few more examples to understand this better. Let's say for the products table, this table, we want to look at the average price by category. Okay, so for each category, I want to look at the average price. But I want to look at only those cases where price is greater than 1,000. So we can see that there are so many prices which are less than 1,000. Okay. So let's say I want to find the average of price as average price from classwork dot products group by 1. Okay. Now this is going to give me the average price for each category. Now I want to filter out, I want to do the group by for only those products whose price is greater than 1,000. So if I say where price greater than 1,000 and then I run this query, see, I get 2 such categories. Now let me break down the problem for you. So how is SQL working through this? So first SQL is doing this, select star from, this is the back end of how this works. Okay, I'm just breaking it up for one example so it's clear for you. Where price is greater than 1,000. First, it is doing this. Okay. So when it does this, there are only 3 entries in the entire table where the price is greater than 1,000. Now, mind you, we are talking about price, the raw column price. If you scroll through this data, you will see that there are exactly 3 columns, 3 rows where price is greater than 1,000. Then it is looking at the rest of the question that, okay, this part we have sorted. Now, what do I want to do in the query? I want to find the average price by category. So in this data, it is going to look at the 2 categories which have been filtered out, which is jewelry and electronics, and give me the average price for each of these categories. So then it will do this. So see, for jewelry, it did an average of those 2 rows where category was jewelry, and because electronics had a single entry with price greater than 1,000, so it simply took that price and pasted it here. So this is how the select logic, the group by with where works. Remember that whenever I'm doing group by with where, it will first filter the data by whatever condition I'm mentioning in the where clause, and then it will go to the group by and see and do the summarization. Okay. We'll do a couple of more on this. So let's say now, let's try and use a different kind of filtering criteria. So in my category, I can see that there are 2 kinds of appliances. So there are kitchen appliances and there are home appliances. So let's say I want to only look at the average price and total number of products where category has the word appliances in it. So we can use like in this case. So we will say select category. Then we want to look at average of price, as I can ignore writing the as because it's optional here. Then I want to do count star as count of records from classwork dot products. Okay. Then let me first write the group by. So group by category. Now here I have to put the condition. So I want to pick those categories which has the word appliances in them. So category like, because appliances is the second word, I can write it like this. This means that I'm not sure if I got the spelling right. Appliances. Okay. Yeah. So I'm saying that the categories which end with the word appliances and can have some letters before appliances, pick those. Okay. Now if I run this query, see those two categories came up. This is their average price and this is the total number of products listed by those categories. Okay. So if you remember from last class, we looked at multiple ways of filtering out your data based on wildcard matches, based on based on between, based on and or not operators. So we can use all of those in the where criteria to make it more sophisticated or make it more complex, and then use it with the group by. Okay. Let's look at some more examples which I have listed out here. Okay, so the next question is, find the count of employees by department for only city Houston. Okay. Okay, just give me 1 second. Okay, all right. So here we are trying to find the count of employees by department. So the group by will be by department. But here you see that we want to filter based on a different field. So let's see if that's possible, because we are doing up till this point, whatever field that we were doing group by or that we were summarizing, we were putting the where condition only on that field. But in this question, they're asking us to find the total number of records by department. So group by will be department, but the filter would be based on city. Let's see if that's possible or not. So we say select department ID, count star from classwork dot employee, classwork dot employee, where city is equal to Houston group by 1. See, it's still able to filter it out. If you go back to the data and first do this filtering, then you will see that it will exactly be these number of records. Okay. So from this question, we understand that it's not always important for the field by which we are filtering to be present in the select clause. Because essentially, if you think about it, this where criteria is working on the entire data set. It doesn't care what you have mentioned in the select statement. It is looking at the entire data set, looking at the filtering criteria and first filtering it out. So technically, it shouldn't matter if I'm filtering by a field which is not a part of my query. And that's exactly what's happening. Okay. Let's look at another question. So here, find the count of employees by department and city whose salary is greater than 100K. Arrange it by count in descending order. So this question, I will give it to you guys to solve, and I will solve it for you in the next class. I'll just highlight this in yellow so I don't forget. So this question, we'll give it a try in next class. You can try it at your end. I will give you the solution in the next class. Okay. The fourth one is a different thing. Okay. So now we understand that how can we filter out the data first and then summarize it. Any questions till this point? Okay. So now, okay, there's a thank you. Okay. Now, what if up till this point, how are we proceeding? We are first filtering it based on a raw field and then we are summarizing it. What if I want to do a filtering based on these summaries that I'm creating? So what if I want to look at this query, and in this query only, I want to filter out only those records where maybe the total count is greater than 5. In that case, I cannot use where, because where essentially will always work on the raw data and then it will do a group by. If I want to filter it on the output of group by, I have to use a different clause called having. If I go back to my query here, the having clause is used to filter groups based on a condition similar to the where clause, but applied to grouped records. So if I want to filter, based on this query, if I want to filter out only those department IDs where the count is greater than 5, then I will have to use a having clause. So let me write that down. First, let me say having. So in the same query, if I want to now filter for records for those department IDs whose total count of record is greater than 5. So essentially my 3 will go and my 9 should go away, because for them the total count by department ID is less than 5. Sorry. Yeah, it's less than 5. So if I run this, see, now 3 is not there and 9 is not there. So a having clause is also a filtering, also helps me filter the final output. But a having is the clause which you will use to filter if you want to filter it based on the aggregation that you have created. If you want to filter the raw data, you use where. If you want to filter the output based on the aggregation, you have to use having. This is the primary difference between having and where. Let's look at few more examples. Okay. Sorry. Okay, so let's say I want to look at the products data and I want to find two aggregations in it. So I want to find the average price and I want to find the total number of records. So I will say select category, average of price, count star from password.products by 1. Okay, let me first run this. So for each category, we now have the average price and the total number of products listed. Now, what if I want to filter this data only where the total count by category is greater than 10? So because I want to base it on top of an aggregation, I have to use having. So having count star greater than 10. So in that case, tools will go away. I think there is home appliances, which has 2 products listed, and tools, which has 2 products listed. For everything else, the total count of products listed is greater than 10. So if I run this output, home appliances and tools should not appear in the final output. So see, home appliances was here and tools were somewhere here. So all of that has gone away. Okay. All right. So this was simple. But let's say now I want to find the sum of salary by city in my employee table, but I want to filter it based on a different aggregation. Let me first find the sum of salary by city. Let's say city sum of salary from classwork dot prod employee by one. Okay. So first I want to do this. For each city, I want to find the sum of salary. Okay. Now, I want to filter out this output by those cities where the total number of employees is greater than, let's say, 70. So, okay. So what do I want to do? In this query, right now I have city and sum of salary. But I want to filter it based on the total number of employees by city. Now, we can see here that the total number of employees is not a part of the query. But having can help me filter out based on an aggregation which doesn't exist in the query. So, if I say count star greater than 70, and I run this query, SQL is going to let me do that. Oh, there are no such records. Give me 1 second. So if I just add count star here, just to see how many records are there, and I run this. Okay, 1 second. So there should be 2 records where count is greater than 70. So if I write ID here, sometimes star will not work. If I run this query now, unrecognized name ID. Hold on. Oh, ID doesn't exist in this table. Let me run this query first. Yes, now it works. Okay, so count star will not work, but we have to mention a name here for the query to work. Okay, small thing that we just realized. So in this query, in having, I used count star and it worked because count star was a part of the aggregation that we were doing. But in this query, because we don't have that count star aggregation present, so we have to mention a particular field name in the having. Small thing that you should keep a note of. Okay. So what are we doing here? If I run this query now. So now, first, the way this query is running is, first it is looking at the data and trying to find the sum of salary by city. So it's finding it for 4 cities first. It's running this part first and giving me the sum of salary for each city. Now in the second part, I am telling it that now filter out the output for only those cities where count of employee ID is greater than 70. So it is essentially looking at, it is implicitly creating the count of employee ID by city and then filtering it out for only those cities where count is greater than 70. If we want to see whether it is actually doing it correctly or not, if I write this down and I say count of employee ID and simply run before the having clause. If I run it like this, now see, there are 2 cities for which the count is less than 70. So when I'm writing this query like this, it is implicitly creating this count of employee ID. It's creating this in the backend, this entire thing. And then it is filtering it out based on this criteria. So the first 2 rows will go away and only the second, third, and fourth row will exist. So looking at this question, what we understand now is that the aggregation by which we are going to use in the having clause doesn't have to exist in my query. I can create a completely fresh aggregation and filter it based on that using the having clause. The only thing that you should notice, if you're using count here, if you're using count star here, it will not work. You will have to mention a field name. And second, very important thing that you should keep in mind when you're working with having is the group by will always be at the level that you have mentioned in the clause. So here, this having count employee ID greater than 70 is always at the level of city. Here, if you want to do it at a different level, if you want to filter out count of employee ID greater than 70 by city and department ID, it will not work. So remember this, that having will work at the same granular level as group by. So if group by is at city level, the having computation will also be at city level. Okay, keep this in mind when you're writing the query. Sometimes, I mean, whenever you're starting off working with having, what I would suggest is write out the entire query first. Like here first we wrote down the entire thing, then run it by group by first without running this having clause. Just run this part of it, then look at this having clause and understand what is going to get filtered out, and is that exactly what you want, is that what your logic should be, and then use the having clause, because then you get a better understanding of how the query is running. Okay, I'll give you one more question on this where we will use all right. So let's say now I want to look at the average salary and minimum salary by department ID, and I want to filter out those department IDs where minimum salary is greater than filter out those records where minimum salary is less than 40K. Okay, so first I will write the group by query. This way, what happens that you have a better control of how the query is going to run and if it is exactly doing what we want it to do. Classwork.employee group by 1. Okay, so if I just run this query now, first thing, so see, this is giving me the average salary and minimum salary by department IDs, and I can see that there's only one department ID where the minimum salary is greater than 40K. Now keep in mind my question or the query that I have in mind, I want to filter out that department ID where the minimum salary is greater than 40K. I only want to retain that record. So I will have to use having min salary greater than 40K. When I run this query, all of these records will go away. And I will only have department ID 10. So remember this, very important, that how do you decide whether you want to use a where or a having? A where is supposed to be used when you want to filter the data first, then do the summarization using group by. A having is going to be used to filter when you want to filter it based on an aggregation. You cannot use this minimum salary greater than 40K in a where clause. It will give you an error. Okay. So having works on the output of an summarization or the output of group by. Where works before you do the group by. Okay. Have this distinction clearly set in your mind, because that's how the algorithm will work. Okay. Let's see if we have any classwork questions on this. I think we had all of these three questions. 1 second. Give me 1 second. I think all three questions are referring to this one only. So in that case, we'll do maybe one of them and I'll give you the rest to try on your own. Okay. So what I'll do is we'll do the last question I'll do. Question number 4 and 5, I'll give it to you guys to try. So I'll just put those in yellow. So I'll remember to give you the solution in the next class. I'll just explain how we have to do them. Okay. So question number 4, find the count of orders by kiosk where sum of value is greater than 30. Now remember in last class, we created a table called records. We created it from scratch. So in that, we want to find the count of orders by kiosk ID where the sum of value is greater than 30. So here you have to first do a group by kiosk and find the count of orders. And then you have to filter it where the sum of value is greater than 30. Okay. So understand the question first and then decide if you have to use first decide group by what field and what aggregation do you need. Then decide if you have to use a group by, if you have to use a where clause or you have to use a having clause. Okay. If you're not sure, start with the data, break it down into multiple parts and solve one part at a time and then connect all the parts. Okay. For the next question, we have to find the sum of price, count of items from products table by category. So the first part is simple. You will have to do a group by category and find these two aggregations. Filter out categories is equal to jewelry and clothing. So we don't want categories, jewelry and clothing. Okay. So we have to filter out two of these categories. So we will use in and we will combine it with not because we want to filter these two categories out. Keep only aggregations whose minimum price is greater than 30. So in this clause, I'll give you a small hint. You have to find two aggregations using this group by. You have to use a where clause and you have to use a having. So similar to the first question that we solved. Here, if I show you this question. So we used a where and we used a having. You'll have to do something similar. So give this a try. I'll give you the solution in the next class. Last question I'll solve for you. This is similar to question number 5. Give me 1 second. I'll just take a sip of water. Any questions or doubts, or is this logic clear where you have to use having, where you have to use where? All right, I'll take that as a yes. Find the count of employees by year of hire date. Retain the records where year of hire date lies from 2020. So 2020 onwards. Okay, find the count of employees by year of hire date. So here I'll introduce you to another function, which is a row-based function. So we want to extract year from hire date. So we will use this formula called extract year from hire date as year. Then we have to find the count of records or count of employees as employee count. Okay, that's the first part. From classwork dot employee group by. Now here we want to group by what? And the second part is retain only the records where the year of hire date lies ahead of 2020. So we have to use, we want to filter it out by this field year. Now that's not at an aggregation level, it's at the raw data level. So I will say where I can either use the entire computation, or I think I can use year also here. This greater than 2020. Let's see if this works. It is working. So let's also arrange this by the year, so that 2021, then 2022, and so on. It appears like that. Yeah. So what did we do here? Up till this point, we were only working with raw date fields. But if I use the raw date field, it will summarize for each individual date that we have. We don't want that. We want to use the year information from that. So the way you do that in BigQuery is you use the extract function. So the syntax for that is extract. In brackets, you mention what date part. I want to extract the year. So year followed by from, and then the date field from which we want to extract the year. Close bracket, give it a name. Then I create the count star because that gives me the total number of employees. From table, then I put the condition because I want to filter out the records for only those cases where year is greater than 2020. I can use my raw hire date also here. So I can say hire date greater than 2020 12/31. So I can use that criteria also. But because I'm creating this field over here, I will use the same here. Okay. Then I say group by the first clause, which is year, order by this. Okay. So this is my first question. The second question is, retain only the records where lowest salary for employees hired in a particular year exceeds 31K. So we want to retain only those records where lowest salary for employees. See, this is a hint for you. So whenever I'm saying lowest salary, highest salary, sum of salary, that means I want to filter it based on the aggregation. So whenever I want to filter based on aggregation, I will have to use having there. So here it is saying lowest salary. That means min of salary for employees hired in a particular year exceeds 31K. So in this same question, if I mention having min of salary greater than 31K, and just to check if this is correctly getting computed or not, I will also write min of salary here. Let me first run this part of the query. Now see, there are only 2 years, that is 2022 and 2023, where min of salary, which I just added to the query here, is greater than 31K. So these two, 2021 and 2024, should go out. I mean, we should not see that when I'm using this having. Let's see. That's happening. See, now those 2 years where the min of salary or the lowest salary was less than equal to 31K are filtered out. Okay. Arrange the output by hire date. That we've already done. So this is my final output. So question number 4 and 5, I will also paste in your chat. So you have that handy. So there are 3 questions that you have to solve. All right. So this is about having clause. Now there is an order of hierarchy in this. So I'll just write it down over here in this only. So whenever you're writing, whenever you have multiple things, like you have group by, where, having, it has to be arranged in a particular order. Otherwise, you're going to get a syntax error. So first comes where clause, then comes from table, then comes group by, then comes having, then comes order by, and then limit. So these are the 6 clauses that we have looked at till now. So whenever you're writing a summarization query and you want to filter by the raw data, the first thing which will come is where. Hold on, where comes before group by? Yes, where comes before group by. Sorry, from will come at the very beginning. Hold on. Yes. So first comes from, you have to mention the table name. Then you mention where. So where, based on where you filter from the raw table. Then you do group by, whichever field you want to summarize by. Then you filter by having. So based on the aggregations that you're creating using the group by, if you want to filter, you use having. Then you do order by. So sort the data in a particular order, final output, and then limit. Limit will limit the total number of output rows that you want to get this that you want to display. So here, if I say limit 1, it will only display this 2022 for me. Okay. All right. So remember this, even if certain criteria are missing, for example, let's say I don't have having and I don't have limit, then also this order has to follow. It will always be from, where, group by. If you don't want to do having, you don't write having and then you write order by. So this hierarchy should always be maintained. Otherwise, you will get a syntax error. Okay. So that completes the group by. So till this point, now we clearly understand how do you do summarization in your data using one field, using multiple columns. How do you filter out your raw data? How do you filter out your aggregated data? We understand all of that. Okay. Now we will start working on a new concept. One second. Okay. So here we have to talk about SQL constraints, but in SQL constraints, there are two constraints which you would understand better if we do ERD first. So we've looked at logical operators, joins we are going to take up in the next class. Today we are going to talk about entity relationship diagram or ERD. Okay, so what is an ERD? An ERD is a visual representation of entities and their relationships between them, okay, within a database. So it helps to illustrate how data is organized and how entities relate to each other. Let me quickly connect my one second. I have to connect a different writing pad now because we'll have to do some diagrammatic representations from this part onwards. Okay. So entity relationship diagram. It is a visual representation of entities. What are entities? Entities are objects, concepts, or things. To simplify, entities mean table in an ERD. So think of it like in a database, you can have n number of tables, and the main USP of a relational DBMS is that all the tables are going to be related to each other in one way or another. That is, you can basically combine two or more tables based on certain keys or combination of keys. So those define the relationship between the tables. And ERD essentially is a collection of all the tables which are present in one database and how they are connected to each other. That's what an ERD is. It's a type of a structural diagram. You can call it like a structural diagram of the database that you're using. Okay. Okay. Now, what are the benefits of using ERD? First, clarity, because it helps you understand that how your data is organized. Now, if I show you this particular Word document, which has been provided by Innovit, so this talks about all the tables which are sitting in different databases. They have given you some 13 or 14 tables, and They are divided into three separate databases. There's a customer database, there's a library database, and there is a employee database. Now, if you just scroll through this, it is very difficult to understand that how these tables are related to each other. Like for example, employee database has two tables, employees table and departments table. In an ERD, you would have a diagrammatic representation of these two tables, and it will also show which field is used to combine both of those tables. Now here you only have two tables. If you go to your if you go to your library database, you see there is 1, 2, 3, 4, 5, 6, 7 tables, and it gets very difficult to understand which table is connected to which table using what. Your ERD basically gives you a diagrammatic representation of that, and we'll create that to see. It's a design tool. It helps database designers and developers plan and visualize database schemas. Now, database schema is also similar to ERD. A database schema, if you remember in the first class we'd spoken about database schema. Database schema means that how all the different elements of a database are connected to each other. Now remember, a database can have not only tables, it can have views, stored procedures, user-defined functions. Yeah, all of these elements can be there. So how they all are connected to each other, that is what a database schema is. And entity relationship diagram only talks about tables, primarily and purely about tables and how they are connected to each other. So a database schema can be thought of as a more diverse ERD. And once you understand how the tables are connected to each other, it becomes easier to create a database schema, because the major part of a database is going to be tables. So how the tables are connected to each other, if you understand that, designing the database schema becomes easier. Communication facilitates communication between stakeholders about database requirements and structure. So this is more about once you have a diagrammatic representation instead of a sheet where all of these tables are listed, it's easier for people to understand that or share understanding about how the database should look like. ERDs are essential tools in database design and management, of course, because of these reasons, in the creation of well-structured databases that efficiently store and retrieve information. Okay. Now let's talk about the key components of an ERD. So the first thing in an ERD is your entity. Entities are represented as rectangles, and they are objects or concepts in the real world that can be uniquely identified. Essentially, what they mean by this is that entities are tables in an ERD. Okay, it is if you want to really define it, it is a concept within a system. So think of them as a particular element which exists in your database. For example, customer, product, employees. These are what? These are tables which have been provided to you. So these are called ERDs in the framework of these are called entities in the framework of an ERD. Attributes are nothing but properties or characteristics of entities. That means these are the columns which exist within your table. For example, a customer entity can have attributes like customer ID, name, and email. What are these? These are column names which exist within the table customer. So in the ERD framework, your column names are called attributes. Okay. Third thing is the R in the ERD, relationship. Relationships illustrate how the entities or tables are connected to each other. They are represented as lines connecting the two entities and describe the type and nature of association. So think of it in terms of what are the keys by which those two tables are connected. That is essentially what your relationship is. Okay. Then we talk about cardinality. Cardinality means the number of instances of one entity that can be associated with each instance of another entity. So in terms of tables, when two tables are connected to each other, It can have a one-to-one relationship. For example, let's say you have a table called customer, which has customer ID, name, and email ID. And let's say there is another table which has the customer's address as well as his phone number. Now, if both the tables are unique at customer level, it's going to be a one-to-one relationship. Every row within customer table and every row within the customer address table is going to be a one-on-one match. So that becomes a one-to-one cardinality. One-to-many means when one row in one table can be linked to multiple rows in another table. For example, with a customer table, one customer can place multiple orders. So when I try to map my customer table with my orders table, for each row existing on my customer table can be mapped to multiple rows in my orders table. So that becomes a one-to-many mapping. A many-to-many mapping means that uh, basically each row in both tables can be linked to multiple rows in the other table. Okay, let's look at, we'll talk about primary and foreign keys in a bit. Let's first look at these cardinalities over here. One-to-one, each entity in a relationship will have exactly one related entity, like the example we spoke of, that if I just draw it out for you, hold on, just open up a fresh sheet. Okay, let me go and choose the drawing. Yeah, so let's say this is my customer table and this is my customer address table. So there is ID here, there is name here, and there is email ID here. This one has ID and physical address and phone number. Now every ID here maps with one ID here. So this is a one-on-one relationship. Now let's say there is an orders table over here. I'll just put the name here. It has the ID, it has an order ID. And let's say it has total price. For each ID, what is the price that this customer has paid? Now this table, if I try to understand it, let's say this is ID, this is order ID, and this is price. Let's say the first ID is 1001. So let's say he has placed an order called ABC001 with price 20. Then there's another order called ABC002 with price 50. Then another called ABC003 with price 100. So when I try to link it to this table, for each ID here, let's say it has one ID called 1001. For each ID here, there are 3 entries. So this one will get mapped to this row, and this row. So that becomes a one-to-many relationship. Correct? Let's look at what they have to say here. This is exactly what they are saying. Many to many, multiple entities can be associated with multiple instances. So here they're giving a different example. They're saying students enroll in courses. Each student can enroll in many courses and each course can have many students. Correct? So if we want to create an ERD for that, so there is one table, which is a students table. Okay. And one table, which is a course table. So each student, let's say how this table will look like. Let's say this is student ID and this is course. So let's say student A has 3 courses. Let's say he's taken up a course in SQL, one in Tableau, and one in ML. And similarly for student B and so on. Now in the course table, for each course, there will be students mapped, and let's say their scores in those courses, their scores. So let's say there is SQL. Let's say there are 4 students in the SQL class. Let's say student A, student B, student C, student D, and their scores. Let's say this person got 100, this got a 95, this got an 80, this got a 70. Similarly, for ML, there are maybe 3 students. Let's say A took C and D, and they have separate scores here. So if you see over here, every student, so A here will be mapped to this course and this course. Sorry, not this course. Sorry, this course and this course. Similarly, student B will only be mapped to this course, SQL. Student C will be mapped to this course and this course. Similarly, if I go the other way around, for SQL, it's going to be mapped to student A and student B and student C and D and so on. So it becomes a many-to-many match. Each entry in both the table can be mapped to multiple entries in the other table. So that becomes a many-to-many merge or a many-to-many match. Okay, so we understand types of relationships. Now let's talk about these 2 keys, a primary key and a foreign key. Primary keys are crucial components in ERD, not just in ERD, in any kind of database, because they uniquely identify each entity instance within a table. So pay attention to the word unique. So that means a primary key are going to be the unique identifiers of a particular table. Okay. So a primary key is very, very important because it helps with multiple things. When we move into indexation, joins, you will see how important your primary keys are. For now, understand that it is a unique identifier of a particular table. And second thing, this primary key can never be missing. It can never be null. These are the main features of a primary key of a table. A foreign key is essentially used to establish relationships between 2 tables. Okay. Now, let's look at a particular database schema. This schema is not fully correct, so I will create the correct schema for you. We'll create this particular schema based on the 4 tables which have been provided to us, and then I'll show you how the ERD for this looks like. So if you go to the very first database, which is customer database, you will see that there are 4 tables. There's a customer table, order details table, and a products table. Let's talk about the first table. Let's create a ERD for the customer database. Let me scroll down, insert blank page. So I'm gonna give a name to this. Customer database ERD. So my first table is going to be the customer table, right? Now within this customer table, what all fields do we have? We have ID, name, email, and phone. And if you see, ID is the unique identifier. Now we know the unique identifier is also my primary key. ID, name, email, phone number. And this is my primary key. Okay. So this is an entity. Customer is a table which is called an entity in NERD, and these are the attributes of the entity, or I think they're called attributes. Now let's define relationship. The second table in customer database is orders table. Now it has three fields: order ID, customer ID, and order date. Now the order ID is the unique identifier for each order. Okay, so this is my primary key for order table. Now customer ID is the unique identifier linking the order to customer. So whenever a field is going to link this table to a different table, that becomes my foreign key. Let's create it then. So the next table in this chart is my orders table. So I'm going to create another box, which is the entity for orders. There's an order ID. There's a customer ID. And there's a order date. Now order ID is the unique identifier, so that becomes my primary key. Customer ID is going to be used to link these two tables. So that becomes my foreign key in this table. In this table, it is my primary key. In this table, customer ID is not the unique identifier. The unique identifier is order ID. Customer ID is used to link orders table to customer table. So in my orders table, customer ID becomes my foreign key. Okay. Let's look at the third table, order details. So order details has order ID, which is the unique identifier for the table. And it is the same field with which it will get connected to the orders table also. So my order ID is the primary key for sure because it is the unique identifier for the order. And it is also used to link it with the orders table. So it also becomes my foreign key. Product ID and quantity. We'll ignore this part for now. So it has three fields, order details, and it is directly linked to my orders table. So I'm gonna create another box here, which becomes my order details. It is linked to my orders table. It has order ID, which is the primary key for sure. Then you have a product ID, and then you have a quantity. Okay. Now order ID links it to the orders table also. So this serves as both primary key and foreign key. We'll ignore what happens to product key. There is a fourth table here. We'll ignore this part for now. We'll first create the products table. So products table has four fields: ID, name, category, and price. This is the table we were working with today, by the way. So product ID is the unique identifier. So that becomes the primary key for products table. And in the order details table, it is the unique identifier for the product ordered. That means this field is going to be used to connect order details to the products table. Now in this table, it is the unique identifier. But in this table, it is not the unique identifier for order. It is the unique identifier only in this table. In this table, it is used to connect it to the products table. So product ID in order details table becomes my foreign key. Okay. If I go back to my table here, so my product ID becomes foreign key. And then I create an entity for the fourth table, which is the products table, which has four fields. One is product ID, which is the primary key also. Then there is name, product name. This table we were working with. Category and price. So this becomes my ERD for customer database. We are defining each of the entity. We are defining the attributes within the entity. We are defining how the tables or the entities are related to each other. And we are defining the primary and foreign key for each entity. So these are the 5 elements of your ERD. This, think of it like a simplistic database schema, which is only based on tables. Once we add views, procedures, uh, user-defined functions to it, that becomes the entire database schema. Okay. Now, if I now let's go back to this. There was a bit of a problem in this schema because here products is linked to orders table, but products is supposed to be linked to order details table. Okay. And in order details table, they've mentioned a new key which doesn't exist in the raw data, which is why I recreated this. Okay. There's a small error in here. So we recreated it. Now, they've also given the explanation which we just spoke about. Okay. Now I'll show you. Now what I want you guys to do is, we worked for customer. I want you to create a schema for library database. Sorry, ERD for library database. So it lists out all the tables. There are, I think, 6 or 7 tables. Try to create an ERD for this. In the next class, I'll show you how it is supposed to be exactly. Try to do it in the same way like we did it for customer database. For employee database, there are just 2 tables. So I'll create this as well for you. So you have it handy. So now I'm going to create a ERD for employee database ERD. Now there are just 2 tables. So I will first create the entity for both of them. Okay. So this is my employee table, which I think we are using the most for all of our summarization. And the next is department. Let's go back to the schema design which is given to us. Employee table has employee ID, name, department ID, hire date, city, and salary. Now, if you see here, employee ID is the unique identifier for each employee. So that becomes my primary key. Department ID is the unique identifier linking employee to department. Now, this is the linking key between employee table and department table. So department ID becomes my foreign key in employee table. So let me create it. So there is employee ID, which is my primary key. Then there is name. There is department ID, which is the foreign key. Then there is hire date. There is city. And I think there is salary. Okay. Now this is linked to my department table, which has 2 fields only, department ID and department name. Department ID is the unique identifier for this table and also the linking field to employee table. So in here, department ID is my primary key and department name. Okay, pretty simplistic. All right. So this is my ERD. I want you to create the same using the last database, which is the library database. If you are getting confused, look at the tables also and try to understand how they can be linked to each other if these descriptions are not clear. Okay. All right. The next thing which I want to cover after this is going to be my constraints. There's a reason why I did not do constraints before, because in constraint, we use primary key and foreign key to define 2 constraints. So that is why, and there are other constraints also. So we'll talk about this first in the next class, and then we'll move on to the other topics. All right. Thank you guys. Good speaking to all of you. Please try out all the things that we have spoke about today, the three questions, as well as try to create the ERD for the library database. And please, before you come for the next class, ensure that all of these tables which have been provided, please ensure that you have already imported all of them within your BigQuery. Okay, because we'll start with joins in next class, and there we are going to connect these tables. Okay. All right, that's about it. Thank you so much. It was a good session. And please let me know if you have any doubts or questions. We'll pick those up in the next class. Thank you. Have a good evening and bye bye. Did I put all the questions here? Yes. Okay.